Okay, so these are all kind of mixed. Most of them are topic 2 as I go. There are going to be some that you'll see, like right here. Some of these are actually combinations of topics. So these are really more topics like 3 and 4. So we'll skip over those. But so let's start just with number 1 here. And I'll let you guys kind of have a few minutes to kind of think about it and see if you can come up with it. And then we're going to, if you want to type in the chat, you can type in the chat, or if you want to unmute and actually answer whenever I, ask for input from you guys, either way is fine, as long as you're participating. If you don't want to unmute or you're not comfortable unmuting and talking, that's fine. But I do need you to be at least typing in the chat then, okay? So number 1, okay, if we read it, it says, consider the composition of the species W, X, Y, and Z below. So there's 4 different particles, 4 different things. And it says, which species is an anion? So there's a couple things here. First off, we have to know what an anion is. And then we have to know what that means in terms of protons, neutrons, and electrons. So can anybody tell me what an anion is? Let's start off with that first.
Is it the what's it called? The thing that only has the positive charge?
So you're close. It does have a charge, but anion is actually the ones with negative charges. So the cations are positively charged, anions are negatively charged particles. So because ion, in general, ion is just something that has a charge. It's not neutral, so it's not an atom. And then specifically anion. And so a little trick that you can remember it is if you look at the word anion, if I look at like the A and the N, and it's kind of like, if I think about it standing for A negative and then ion. So if you think of the first 2 letters, the AN standing for A negative, so then it kind of looks like A negative ion. And then the other thing is for cations, and this is kind of the little cheesy thing that I always say for people to remember. If you think of, if you think of a cat, right? Okay, there's a little kitty. Oh, isn't it cute? And cats have paws, right? And so cations are positively charged, okay? So that's my little jokey, corny thing. So cation, because it has the cat at the beginning, and if you think cats have paws, so cations are positively charged, whereas the anions, it's like saying a negative ion. The other thing for anion is, if you think about it, it kind of looks like the word onion. And if you ever have cooked or worked with onions, if you chop onions, what usually happens to you?
You cry.
Mm-hmm. So usually there's some sulfur compounds usually in the onions that react with some of the tissues in your eye, and they make you cry, which is typically a negative feeling. So if you think about onion and anion kind of looking similar and thinking about associating that negative feeling with that. So those are a couple of tricks or shortcuts to try to remember what those 2 words mean. So once we know that anion means it has supposed to have a negative charge, then the next thing I have to think about is, what does that mean in terms of my protons, neutrons, and electrons? So if something is going to have a negative charge, what does that mean for the numbers of these particles? Which particles do I need to look at, I guess we could ask.
You really have to look at the protons and electrons, but more electrons, because they need more.
So really, this middle column, we can cross this out. That's really just extraneous information, because neutrons don't have anything to do with charge. They only affect the mass. So if they were asking us about the mass number or something with isotopes, then we would need the neutrons. But they're asking us about anions, which have to do with charges, and that means we need to look at protons and electrons. And specifically, since we're looking for an anion that's negatively charged, am I going to have more electrons or more protons?
More electrons.
Yeah, so because it's an anion, and so this is why we had to know that anion is negative, because we have to know that negative means more electrons than protons. So now looking at that, which one of these has more, which answer choice has more electrons than protons? What do you guys think?
The Z species.
More electrons than protons?
Oh,
Did I say it backwards? Sorry. Remember, we're looking for the one that has more electrons.
it's the species W.
Yeah, so it's W. Because if I look, there's 10 electrons, but there's 9 protons. All the other ones on X, they're the same. On Y, they're the same. So those wouldn't be ions. Those would just be neutral atoms. And then on Z, the protons are more. So Z would be not an anion. Z would be a cation. Okay. So W is the one, and that would be answer choice A. So this is, an example of a typical question. So what we had to know on this, we had to know some vocabulary, like we had to know what an anion was, the definition of that. And then we had to know what that meant in terms of protons, neutrons, and electrons. So like, what did we need to look at to figure that out? All right, so number 2 on here, this relates to what we just talked about on Monday. It says energy levels for an electron in a hydrogen atom are, and then we have evenly spaced, farther apart near the nucleus, closer together near the nucleus, or arranged randomly. So this is really a straight up like knowledge memorization type of question. You have to think about when we drew all those Bohr models and we looked at those emission and absorption spectrums for hydrogen atom on Monday. Did the energy levels, were they all evenly spaced apart? Were they closer together or farther apart, near the nucleus? I can tell you right now, D should be eliminated. It's never random, okay? So it's got to be A, B, or C. So thinking back to what they looked like on Monday, what do you guys think that this one would be?
I want to say B.
You want to say B? Anybody else y'all agree with Ashanti, or what do we think? Let's see who else we got in here. Javon, what do you think? Any input on this one? Okay, so we got one person for B. We got another person saying C. So I will say, yeah, it's not A. They're not even. So it has to be B or C. So if we went back to, if I go back to the notes from Monday, so let me go back to them. Oops. So here's one of our little pictures with the energy levels. So we can look at the one where it's this entire Bohr model with the circles, or we can look at the one with the lines. So remember, down energy level 1 here, or energy level 1 here, that's closest to the nucleus. So closest to the nucleus are those energy levels, those lines, are they farther apart or are they closer together?
Further.
They're further apart. Okay, look at the distance between them. They get closer together as you go up higher. Same thing here. That's further apart. Okay, so that's just straight up, you had to know your you had to know what that Bohr model and the energy levels looked like. Okay, so they're always going to be further apart, because as you move away from the nucleus, they get closer together. And remember, we call that convergence. So as they get further apart, they converge, and converge means they get closer together. So higher energy levels are closer together, lower energy levels close to the nucleus are going to be further apart. All right, so let's see this one. So this one, it's topic 2, but this also kind of crosses over into topic 3, which we haven't done yet, which is the periodic table. But I know you guys learned about the periodic table last year in chemistry, so let's see if we can figure out this one from kind of memory of last year and our topic 2 from this year. So this one says, what is related to the number of electrons in the outer main energy level? So remember, the outer main energy level, that's our highest energy level. So the number of electrons in that outer main energy level, those are my valence electrons, because they're in the outermost energy level. So they're asking which of the following is related to the number of valence electrons in the energy level elements from the alkali metals to the halogens. So if you remember from last year, if I had a periodic table here, okay, I don't draw very well, but there it is, okay. The alkali metals are over here in group 1. The halogens are this next to last group over here in group 17. So they're asking, like, as we go across from the group of the alkali metals over to the halogens, what relates to the number of valence electrons, the group number or the period number? So remember, the periods are the horizontal rows. The groups are the vertical columns. So which ones? What do you think?
Group.
Yeah, it's the group. If you remember last year when we learned about periodic table in our classes, if we needed to identify the number of valence electrons for an atom, we always looked at the group number because it corresponds. Like you have 1, 2, and then over here you have like 13 is 3, 14 is 4, all the way to the halogens group 17, they're going to be 7. Okay. And so it is group number, which is only number 1, which is A. Period number, do you guys remember what period number corresponds to? It doesn't correspond to the number of valence electrons, it corresponds to something else. You got anybody remember from last year? So the period number corresponds to the number of energy levels. So if I'm on like the third period, period 3, that means my atom would have 3 energy levels in its Bohr model. If I'm on the 5th period, it's going to have 5 energy levels on its Bohr model. All right, we're going to skip all of those. All right, let's look at number 7. This is another one kind of similar to that first one. We're having to look at protons, neutrons, and electrons, but instead of them just giving us the word anion, they actually give us a specific ion, a fluoride ion, and here is the symbol that they give us. So a lot of times on the test questions like this, they leave off the atomic number. So, you know, when we learned about it, we said, well, you always have your element symbol, and then up in the top left, you have your mass number. If there's a charge, the charge will be on the top right. And then we said, you're always going to have the atomic number down here in the bottom left. So if I look up fluorine on the periodic table, its atomic number is 9. But a lot of times on test questions, they will leave the atomic number off. The reason they do that is because they know that you have a periodic table to look at for your test, and they know you can look up F, you can look up fluorine, and you can see on the periodic table that its atomic number is 9. So a lot of times they don't put the atomic number because they know it's really easy to find, okay? So if we look it up on the periodic table, fluorine is atomic number 9, so I could fill that in. So now, what is the correct number of protons, neutrons, and electrons? Protons are pretty easy because actually all the answer choices are the same, so I don't really even need to check the protons. They're all 9. How many neutrons is this going to have?
10.
Yeah, so it's going to have 10 because remember I would subtract 19 minus 9. So I can get rid of D because D has the wrong number of neutrons. So now I've narrowed it down to A, B, and C. So now I need to look at the electrons, okay? Is it going to be 8, 9, or 10? So based
Also
on
gonna be 10
why is it going to be 10?
because of the negative charge at the top.
Yeah, exactly. So remember when they have negative charges, those are the anions, which means they're going to have more electrons. And so if it has -1, that means it gained 1 electron. So originally it started with 9 because it always starts with the same as the protons, the atomic number. And if it has a charge, then it either increases or decreases. In this case, it increases by 1. And so that means that it would have 10 electrons. So my answer would be C on this one. Can't be B because the electrons and protons are not the same. And then A would be if it had a +1 charge, it would be A, but it has a -1, so it has to be C. All right, so 8, this is similar to what the previous one we did, that this is related to the topic from Monday. So it says, which statement is correct for the emission spectrum of the hydrogen atom? So I'm going to give you guys a minute to read through because you have to, this is a question where you have to read all 4 answer choices and you have to determine which one is correct and which 3 are incorrect. Okay, so this is asking about that hydrogen emission spectrum, which I'm gonna, if I jump back over here, just so we can look at it really quickly. They are talking about this right here. So this is the hydrogen emission spectrum. So I have, some of the lines are in the UV radiation area, some of them are in the visible light area, and some of them are in the infrared area. And it depends on what energy level they go down to. But this is the hydrogen emission spectrum. This is what it looks like. So this is what they're asking about for this question. So in your mind, you have to kind of picture this image, okay, when you're answering this question. So if we go back to the actual question, oops. Now, A says the lines converge at lower energies. Is that true? What do you think?
No.
No, that's not true. That's similar to the answer we had on the other question further up. They actually converge at higher energies when you get further away from the nucleus. So then B, it says the lines are produced when electrons move from lower to higher energy levels. Is that true or no?
No.
That one is not true. The reason that one's not true is because the question asks about the emission spectrum. And remember, we talked about on the emission spectrum, all the arrows are pointing downwards because they're going from higher to lower. If they're going from lower to higher, that's not emission, that's absorption. So that has to do with knowing this word emission means that they're going from higher energy levels, they're falling back down to lower energy levels. That's when they emit energy. C says the lines in the visible region involve electron transitions into the energy level closest to the nucleus. So for that one, again, if you picture this diagram, the visible ones are right here. The visible ones are these right here. These are the visible ones. The other ones are UV or infrared, okay? So do these lines for the visible light, do they fall to the energy level closest to the nucleus?
No, they don't.
No, they don't. The closest one would be N equals 1. That's the ground state, okay? So that one is not true because the visible light ones, they only fall to the second energy level, not the first one. So by process elimination, it probably has to be D, but let's check it anyway just to verify. D says the line corresponding to the greatest emission of energy is in the ultraviolet region. So if I go back to this diagram again in our notes, which lines are going to have the most energy or the highest energy?
UV.
Yeah, it is going to be the UV right here because remember we talked about that the longer the lines, the higher the energy, and UV has higher energy than visible or infrared on our electromagnetic spectrum, okay? So that one is the only one that is true on that one. So again, on that one, really, you had to kind of picture that diagram in your head to kind of answer that question. All right, let's see. Okay, those are other topics. All right, let's see. Number 12. How many valence electrons are present in an atom of an element with the atomic number 16? So this is where we would need to look up on our periodic table because we need to know what element is atomic number 16 because that's going to help us figure out. So if you don't have a periodic table handy, you might want to open one up in another tab or something. But can anybody tell me what atomic number 16 element is?
It's oxygen.
You're close. You're in the right group.
It's sulfur.
It's sulfur. So oxygen's mass is 16, not its atomic number. Sulfur's atomic number is 16. Okay. So yeah, I think the reason you said oxygen, you were thinking of its atomic mass, which is 16 for oxygen. So sulfur's atomic number is 16. Okay. But it is right below oxygen on the periodic table because they are both in group 16 or group 6A, okay, depending on which number system you use. So since sulfur is in that group, how many valence electrons is it going to have?
2. Right?
Look at this group number. 16 or 6A. Remember, the group number corresponds to the number of valence electrons. So sulfur is in, if you do this one with the 16, then you just drop off the 1. If you do the one with the A, then the number matches exactly. So anything in group 16 or group 6A, they all have 6 valence electrons. So if I were to draw their dot structures, they look like this. Okay, they have 6 valence electrons like that in their outermost shell. All right, so let's look at this one, because this one number 13 involves doing average atomic mass, okay, which is, requires calculation, but remember, on multiple choice questions, you have access to a calculator, okay? So you have to kind of think in terms of like rounding your numbers off and using kind of the answer choices to help you figure out things. So this one says an element Z, doesn't matter what it is, it has 60%. So 60% is this isotope and 40% is this isotope. So it's not split 50-50, okay? So if we look, the masses we have 69 and 71, right? So 69, 71. If they were split 50-50, then our average would be right in the middle. It would be 70. But they're not split 50-50. So I can eliminate C right off the bat, because that's definitely not going to be it, because they would each have to be 50% for it to be that one, because that's right in the middle of 69 and 71. But they're not. It's 60-40. So knowing that the percentages are 60-40, which isotope is going to affect the average more? Is it going to be the 60% or the 40%? So when we have these percent numbers like this, if they're not split equal, if they're not 50-50, then we talked about in our notes for topic 2, part 1, that the higher percentage is going to affect the average more. So the 60%, that is going to make the average be closer to that value. So the 60% is for the one with the mass of 69. So that means the average is not going to be, it's going to be closer to 69 than it is to 71. Okay. So there's no way it can be D, because D mathematically, that doesn't make sense, because that one is actually closer to 71 than to 69. Do we understand why I'm saying that? We understand why that 60% makes it go that direction and not higher? Because again, if I'm looking at this like a number line, if it was 50-50, it would be right here in the middle at 70, but it's not. The 69 has 60%. So my average is going to be slightly closer to the 69 than to the 71. So then between A and B, which of these really would make the most sense? Because both of them are less than 70. They're both closer to 69 than to 71, but one of them makes more sense than the other one. What do you guys think it would be? Looking at the percentages. So think about, we got 60-40. So that's pretty close to 50-50, right? It's not 50-50, but it's pretty close. It's not like we have 80% and 20% or something like that.
Yeah.
So knowing that it's not split 50-50, but it's kind of close, that means that even though the 69, even though it's 60%, that's only going to affect it a little bit, not a lot. So keeping that in mind, like logically speaking, the answer that's probably the most sense or makes the most sense is B, because it's just a little bit lower than 70. So it is closer to 69 than to 71, which makes sense for these percentages, but it's not way close to 69. Okay, for it to be 69.2, we would probably have to have like 80 or 90% be 69, and then only 10 or 20% be the 71. So this is where you have to kind of use number sense and think of like the percentages and how they would affect the averages, because we don't have a calculator and they're not expecting us to actually calculate it. Oop, I lost it for a second. Hold on. Okay, now it's back. So this is where, like I said, you have to kind of use what we call number sense and think logically about your numbers. Number one, you should have eliminated C right off the bat because there's no way it can be split 50-50 in the middle because of the percentages. Then you should have eliminated D because since the 71 only has 40%, there's no way it's going to be closer to 71 than to the 69. And then once you get down to A and B, then that's where you have to look at the actual numbers for the percentages. Yes, the 60% for 69 is higher than the 40%, but it's not outrageously higher. And so really B makes the most sense, like mathematically. All right, 14. What is the difference between two neutral atoms represented by the symbols CO and Ni? So CO is going to be cobalt, Ni is nickel. So if we look them up on the periodic table, they're different elements, obviously, so they have different atomic numbers. So cobalt, if you look it up, its atomic number is 27, and nickel is 28. So what's the difference between them, do you think? And it's notice it says neutral atoms.
I think it's D.
You think it's D? I think you're right, but I just want to verify. So I'm gonna scroll down here to the key because I don't want to tell y'all the wrong answer. Oops. Yes, you're right. 14 is D. I figured it was D, but so yeah, so for sure we know that protons and electrons are different because if they're different elements, they have to have different numbers of protons. And if they're neutral atoms, then that means the protons and electrons are the same, which means that their electrons would also be different. And then most likely also the neutrons will be different because they have different atomic masses or different mass numbers on the periodic table. So it makes sense that it would be D, that all of them are going to be different. Okay. Let's see, I'm going to scroll back here.
Because at first the neutral threw me off.
Yeah.
So now, wait a minute.
Yeah, neutral just means they're telling you that they're not ions because technically, like, I guess if you had like a nickel ion, and maybe it had lost one electron, then it would have the same number of electrons as cobalt since they're like right next to each other on the periodic table. So that's why I think they said neutral atoms, so that you know that each one of them, the cobalt would have 27 electrons and 27 protons. Nickel would have 28 electrons and 28 protons. So both of those would be different. And then most of the time, your neutrons will definitely be different as well for different atoms because you always increase your neutrons as you go through the periodic table as well. Oh, come on. So we're going to do 17 and 18. So 17, it says information is given about 4 different atoms. So we get W, X, Y, Z. They give us the neutrons and the protons for each one. And it says which 2 atoms are isotopes. So this is another one where we have to know, number 1, what is an isotope? What is that definition? And number 2, what does that mean in terms of our particles? Okay. Just like that other question earlier asked about ions. Okay. So first off, what is an isotope? What's the basic definition of an isotope? Because if we don't know that, it's going to be hard to answer the question.
It has the same elements and atomic number.
Yeah, so it has the same atomic number, which means that it's going to have the same protons, right? Because it is the same element, like you said. So same element implies same atomic number, which is the same protons. What's different about it, though?
Neutrons.
Yep, the neutrons are going to be different. So what we're looking for on here is we're looking for which 2 atoms have the same number in the proton column, but different numbers in the neutron column. So we have to kind of compare and figure out which pair of atoms is going to be the correct answer. So really, I mean, honestly, it's pretty easy. I can just look at the protons because there's only 2 that have the same number of protons, W and Z, because they both have 18. Nobody else has the same number of protons. So it can't be X or Y. And then if we check the neutrons, they do have different neutrons. Okay. They have different neutrons. So W and Z which would be answer choice B. I will tell you, if you don't remember your definition of isotopes, some of you guys might have picked A, because they have A, the answer is A for W and Y. They have the same number of neutrons, but different numbers of protons. So if you don't remember that definition for what an isotope is, and you're just looking at like, oh, which, maybe something that's the same, you might accidentally pick A if you don't remember which one is supposed to be the same and which one is supposed to be different. Okay. All right, last one. Okay. This is back to our new topic for Monday. So this one's talking about the line emission spectra again. So it says, which is correct about a line emission spectrum? So first off, there are two answer choices that should be automatically eliminated right off the bat. Can anybody tell me which two answer choices should be eliminated first? It has to do with a word in the question.
Low to high.
Well, okay, so let's think about this. Emission spectrum, if you emit, if you're emission or you're emitting, are you absorbing or are you releasing energy?
Duh.
So if it's an emission spectrum, you're emitting energy, which means you're releasing energy. Remember, the other type of spectrum is the absorption spectrum. The absorption spectrum has to do with absorbing energy. So A and B should be eliminated right off the bat because they say absorb energy, which is not emitting. Emitting has to do with releasing energy. So then from C and D, the other part that's different on C and D, this one says they move low to high. This one says they move high to low. So which one would be correct for emission?
High to low.
High to low is going to be correct because remember, that's the ones where the arrows point downward and they're emitting the energy as they fall back down. They're releasing it. Absorption spectrum, they'd be going up and they'd be absorbing energy. So again, that's about knowing that that term emission means that it corresponds to them going from high to low. They're falling back down, and that corresponds to releasing energy or emitting it. Okay. All right, we are going to stop there. If I can get it to work with me here.